Hello everyone, I'm Yusuf Kemal Pilanalı. Today I will be presenting you the capacitors and the way I call them, the unsung heroes of electronics. Like we hear mostly about the other things like resistors, transistors, but we don't hear much about capacitors. Today I will be presenting you what are those little pieces are. They're tiny, invisible, and absolutely essential. So let's start by what is a capacitor. So let's think of a capacitor as a temporary battery. It's not big, it's tiny. It can it can store the electrical energy like the other batteries does, but it can be used as a temporary battery. It stores electrical energy by accumulating electric charges. It doesn't generate new electrons. It just holds them and just ready to release when needed. So let's talk about the core components of it. We have two plates and one separator, like two conductive metal plates and a one separator on the middle. And the middle piece on is a dielectric, so it can let the electricity go to the other way. And the material is sandwiched with the dielectric material is sandwiched between the plates. These dielectric materials I talked about include glass, ceramic, plastic, etc. A lot of things. So, how capacitors store energy? Charge. We said it can hold the energy for a while and then release it when needed. But how does it work? Like when voltage is applied to our capacitors, the opposite charges accumulate on each plate. An electric field develops across the dielectric, so storing energy, it it stores the energy without any current actually passing through it. Voltage, then file forms, then the charge gets stored. And we talk about the types of dielectrics, but we didn't talk about the types of the dielectrics. In high voltage occupations, ceramic and mica dielectrics can handle it. High frequency circuits, just air and little minimized plastics. And energy density, like some specialized materials maximize charge stored in minimal space. Like a little transistor can store much charge. So we know the capacitance, it's measured in farads, and it was named after Michael Faraday. In practice, most capacitors are measured in microfarads or picofarads because farad, let alone, is a big number. So when you are making a circuit, you will probably use the one that contains microfarad. And like larger plates have more surface to hold charge, and closer plates have stronger electric field, and higher dielectric constant is more efficient storage. And what was the surface I was talking about? The electric surface. Like the larger the electric surface we are talking about, the more surface to hold the charge, means the farad will be higher. We have distance between electricities, like the what we are talking about, what determines the capacitance of the farad. And the distance, when the distance is closer, it's simply stronger. And we have the contestants of dielectric, and when it's higher, it's more efficient. So we have a quick history of the capacitors. In 1745, 1746, Abel von Kleist and Peter von Muschenbroek independently invent the Leyden jar, you're seeing on the picture. A weather-filled glass jar stores the static electricity, like the first thing that wasn't a battery but hold the electricity for a while. And when we came to the 19th century, paper, mica, and oil-based dielectrics emerged, and capacitors became more practical components in early telegraph and radio systems. And when we came to the 20th century, ceramic and electrolytic capacitors are mass-produced, enabling radios, TVs, and early computers, like any other electrical device. And when we come to today, we have supercapacitors and nanoscale capacitors we use in computers, power everything from smartphones to electric vehicles. We have four types of capacitors. The ceramic capacitors, it's high frequency use like X-ray machines, RF circuits. We have film capacitors. They're timer circuits. They're used in timer circuits like clocks, alarms, audio equipments. And we have electrolytic capacitors, and they're the ones that looks like a battery, and we use it in our circuits mostly. And we have supercapacitor. It's not for our little devices. It's for the electrical cycles, that bigger devices. So, in conclusion, the capacitors are the essential building blocks of our modern electronics. Even a simple calculator uses a capacitor, and even a supercomputer needs a capacitor to run. So they can store energy, filter signals, stabilize power, and enable the functions we rely on every day. They can store energy, filter signals, as I said, and enable innovation. It's a little piece, but it has a big effect on our modern technological devices. Thanks for listening to me. That's all I wanted to present you.